When should software engineers use a linked list data structure? Imagine working with data that needs to be constantly modified, with elements frequently added or removed, and where the order of items matters. This scenario highlights situations where understanding the strengths of linked lists becomes essential. Unlike arrays, which store elements in contiguous memory locations, linked lists consist of nodes where each node contains data and a reference to the next node in the sequence. This structure allows for dynamic memory allocation and flexible data management. Software engineers should consider using linked lists when their application requires frequent insertions and deletions at arbitrary positions within a collection. For example, if a program needs to add or remove items from the beginning or middle of a list often, linked lists can perform these operations more efficiently than arrays, which may require shifting multiple elements. The time complexity for insertion or deletion at the beginning of a linked list is constant, meaning it takes the same amount of time regardless of the size of the list. In contrast, arrays may need to shift subsequent elements, resulting in linear time complexity. Another scenario involves applications where the total number of elements is unpredictable or changes frequently over time. Since linked lists do not require pre-allocated memory for all elements, they are suitable for situations where memory management needs to be dynamic. This is especially relevant in systems with limited resources or where memory fragmentation is a concern. Linked lists are also advantageous when implementing data structures such as stacks, queues, or adjacency lists for graphs. These structures often relying on the ability to efficiently add or remove elements from either end or in specific positions. For instance, a queue can be implemented with a linked list to allow constant time in queue and dequeue operations. However, it is important to recognize that linked lists are not ideal for random access operations. Accessing an element at a specific position requires traversing the list from the beginning, which results in linear time complexity. Therefore, if frequent direct access to elements by index is necessary, arrays or other data structures may be more appropriate. In summary, software engineers should opt for linked lists when their applications demand dynamic, flexible data management with frequent insertions and deletions, especially at the beginning or middle of the collection. They are particularly useful in implementing other data structures and managing unpredictable or changing data sizes.